On December 19th, 3 Atlas shows clear signs of undergoing internal transformation. Thermal lag prevents heat and pressure from being released immediately, allowing them to accumulate quietly within the core until a threshold is reached, triggering asymmetric jets. These jets generate a persistent lateral thrust that shifts 3I Atlas' trajectory away from the predictions of standard orbital models. Once measurement errors were ruled out through both ground-based observatories and space-based instruments, the orbital equations had to be revised to reflect the growing influence of non-gravitational forces. This recalibration not only restores accurate tracking of 3 Atlas's motion, but also reveals a deeper picture of internal restructuring, gradual drift of the spin axis, and a continuous feedback loop between material outgassing, solar illumination, and rotation. December 19th marked a series of turning points for 3I Atlas developments that we will explore in detail next. Before examining measurements and calculations in detail, it is important to step back and recognize the broader physical context in which 3I at last is now operating. 3I at last is no longer behaving as a body guided solely by external gravity, because the object is actively generating its own thrust through the release of gas and dust from its interior. That self-generated push, subtle but persistent, has introduced a sideways component into the motion of 3 at last that diverges from what standard NASA models would predict for a passive traveller. Observations gathered from ground-based telescopes and spaceborne platforms indicate that this displacement does not arise from chance or error, but from internal changes unfolding within 3I at last itself. Newly activated jets, or a gradual modification of the spin axis under sustained solar heating, appear capable of redirecting how material escapes the surface. As these processes unfold, the resulting forces act unevenly across the body, altering its trajectory without requiring any external intervention. What makes this moment distinct is not the magnitude of the deviation, but its implication. 3. Atlas is revealing that interstellar visitors do not remain frozen relics as they pass through foreign star systems. Instead, 3I Atlas demonstrates that exposure to a new stellar environment can trigger physical evolution, restructuring internal pathways and reshaping how the object interacts with space. In witnessing this behaviour, we are not merely tracking motion, but observing adaptation in real time. 3 at last invites deeper questions about structural resilience and long-term stability, because the changes underway will influence how this object ultimately departs our region of space. The chapters that follow do not seek immediate answers, but explore the evidence that transformation itself is already in progress. To reconcile the data, the orbital model for 3I Atlas had to be adjusted in a way that is rarely required, because the non-gravitational parameters usually treated as small corrections now demanded a stronger role. 3I Atlas was effectively telling the equations that the gentle assumptions about symmetric outgassing no longer applied, and that some component of force was pushing the object laterally through space. This did not suggest danger, and it did not suggest intent, but it did suggest that 3 Atlas was responding to internal processes that had changed since the previous solution was computed. As the revised calculations settled into place, the mismatch transformed into a message, because 3 Atlas could now be followed accurately again, yet only by accepting that its behaviour had shifted. 3 Atlas was still obeying physics, but it was no longer obeying the simplified version of physics that works when an object behaves the same way from one day to the next. In that quiet recalibration, 3 Atlas revealed the first sign that this interstellar visitor was not merely passing through unchanged, but was actively adjusting to the stresses of a star it had never encountered before. The numbers no longer matched, because 3I Atlas itself was no longer matching its earlier state, and that realization marked the true beginning of the story, not as a mystery to be solved quickly, but as a process to be followed slowly. As the discrepancy persisted, the possibility that the anomaly came from flawed instruments began to fade, because measurement errors usually scatter randomly, while the displacement seen in 3 Atlas showed discipline and direction. 3 Atlas appeared offset in the same orientation night after night, which is not how atmospheric distortion behaves, and not how timing glitches announce themselves when clocks slip or shutters misfire. When astronomers speak of error, they expect chaos, yet the behaviour associated with 3 Atlas displayed consistency, and consistency is the signature of a physical cause rather than a technical failure. Each observatory involved repeated its reductions, independently recalculating star fields, recentering frames, and rerunning astrometric solutions from raw data. 3 Atlas remained stubbornly displaced even after these revisions, as though the object itself were anchored to a position the equations had not anticipated. The confidence intervals tightened instead of widening, and that tightening told a quiet story because increasing certainty around a wrong prediction forces the prediction, not the data, to change. When comparisons were extended across hemispheres, the argument for error weakened further because telescopes separated by oceans do not share the same atmospheric columns or local distortions. 3 Atlas showed the same offset from Europe, from the Americas, and from southern stations that had no overlap in observation windows. If the discrepancy had been caused by a single faulty reference catalogue or a misaligned detector, the effect would have fractured across locations, yet 3 Atlas remained unified in its deviation. The decisive moment came when space-based observations entered the analysis, because instruments above the atmosphere eliminate entire classes of uncertainty at once. 3 Atlas appeared in coronagraph imagery with the same lateral displacement matching the ground-based data within margins that could not be dismissed. At that point, the idea of measurement error lost its last refuge because independent methodologies had converged on the same unexpected result. What mattered most was not the size of the shift, but its orientation, because 3 Atlas was not simply arriving early or lagging behind along its orbit. 3 Atlas was moving sideways relative to its predicted path, and sideways motion demands a force that is neither gravitational nor incidental. Gravity pulls inward and forward, while error blurs outward in all directions, yet the motion of 3 Atlas traced a line that belonged to neither category. Once that realization settled in, the discussion changed tone, and the room grew quieter rather than louder, because this was no longer about correcting a mistake. 3 Atlas was behaving in a way that required acknowledgement, not explanation, and acknowledgement is the moment when data becomes narrative. By eliminating error as a cause, the observations narrowed the field of possibilities, guiding attention away from instruments and toward the object itself. In that narrowing, 3 Atlas emerged not as a misplotted point of light, but as a physical body undergoing change, and the certainty of that conclusion rested not on speculation, but on the absence of any remaining alternative. Once measurement error had been ruled out, the only remaining option was to return to the equations themselves, because the mathematics describing the motion of 3 Atlas could no longer be treated as a finished product. Orbital solutions are not static declarations, but living models continuously refined as new data arrives, and in the case of 3I Atlas, the incoming observations demanded more than a minor adjustment. The predicted path of 3I Atlas still described a graceful curve shaped by gravity, yet gravity alone could no longer account for where the object was actually appearing against the background stars. To rewrite an orbit is not an admission of failure, but an acknowledgement that the system under study has changed, and that principle applies especially to active bodies like comets. 3 Atlas was therefore reintroduced into the solver, with its non-gravitational terms no longer constrained to their earlier assumptions, allowing the equations to explore a wider space of possible forces. In practical terms, this meant permitting 3 Atlas to experience thrust that did not align neatly with its direction of travel, a concession rarely required, unless the physical behaviour of the nucleus has evolved. As the model iterated, something subtle but important occurred, because the fit improved only when a stronger lateral component was introduced. 3 Atlas could be tracked accurately again, but only by accepting that it was being pushed sideways by its own activity, rather than merely sped up or slowed down along its path. This change did not overturn celestial mechanics, yet it expanded the description of how 3 Atlas interacted with its environment in a way that earlier solutions had not captured. What made this revision meaningful was its stability, because once the sideways force was included, the residuals collapsed into a pattern that made sense. 3 Atlas stopped arguing with the mathematics not because the object had settled down, but because the mathematics had finally begun to describe the object as it truly was. In that moment, the rewritten orbit became less of a correction, and more of a translation, converting raw motion into physical understanding. The new solution suggested that 3 Atlas was no longer venting material in a balanced or symmetrical way, which is often assumed when an object is far from the Sun. Instead, 3 Atlas appeared to be responding to internal conditions that had shifted over time, producing thrust from regions that were either newly exposed or newly activated. This interpretation did not require sudden explosions or catastrophic events, only a gradual rearrangement of how heat and pressure moved through the body. As the updated orbit propagated forward, it carried implications beyond simple position forecasts, because future predictions now depended on whether the current pattern of activity would persist. 3 Atlas could continue along this revised trajectory if the internal configuration stabilized, or it could demand yet another rewrite if further changes occurred. In that uncertainty, the rewritten orbit became a snapshot rather than a conclusion accurate for the present but provisional by nature. By allowing the equations to evolve alongside the object, researchers accepted a deeper truth, which is that 3 Atlas was not merely passing through the solar system unchanged. 3 Atlas was actively rewriting its own story through physical processes unfolding beneath its surface, and the mathematics was following behind, adjusting step by step. The orbit had to be written again because the traveller itself was no longer the same as it had been before. As the revised orbit settled into place, the sideways component embedded within the equations stopped feeling like an abstract parameter and began to resemble the first measurable footprint of a different kind of influence. 3 Atlas was still governed by gravity, yet gravity was no longer telling the whole story because the object was now responding to forces generated from within rather than imposed entirely from outside. This distinction mattered because internal forces do not announce themselves abruptly, but accumulate quietly until their effects become impossible to smooth away. In most cometary cases, non-gravitational forces act like gentle corrections, nudging an object forward or backward along its path as gas escapes more strongly from the sunlit side. 3 Atlas did something less cooperative because the dominant correction was no longer aligned with motion, and alignment is the expectation when activity remains balanced. When that expectation fails, it suggests asymmetry not in the mathematics but in the physical body producing the thrust. The first hint of this alternative force did not arrive as a dramatic jump but as persistence, because every new observation reinforced the same directional bias. 3 Atlas continued to lean into that bias day after day, as though some internal configuration had crossed a threshold and was no longer able to return to its earlier state. This was not the signature of a transient flare which would fade quickly, but of a structural shift that had begun to assert itself over time. As analysts examined the direction of the lateral force, they noticed that it remained coherent rather than wandering, which narrowed the range of explanations. 3 Atlas appeared to be venting material from a region that had become dominant either because it had newly opened or because other regions had fallen silent. Such dominance creates imbalance, and imbalance produces torque, which in turn redirects motion in ways that pure gravity cannot predict. The significance of this realization lay not in the magnitude of the force, which was still small by everyday standards, but in its consistency. 3 Atlas was being pushed in the same sideways direction, repeatedly implying that the underlying cause was anchored in the object's structure rather than in momentary surface effects. This anchored behavior hinted at depth, suggesting that processes beneath the surface were now participating in the interaction with sunlight. As the days passed, the language used to describe 3 Atlas began to change, subtly shifting from certainty toward vigilance. 3 Atlas was no longer treated as a passive body reacting predictably to solar heating, but as an evolving system whose internal responses had become central to its motion. That shift did not imply danger or instability in an immediate sense, yet it did imply that the object had entered a phase where future behavior could not be assumed from past trends. The first sign of a different force, therefore, was not dramatic motion but altered interpretation, because the data forced observers to reconsider what kind of object they were following. 3 at last remained a point of light against the sky, yet beneath that point lay a complex interior, adjusting itself to stresses it had never encountered before. In recognizing that adjustment, the observers acknowledged that they were no longer merely tracking a trajectory, but witnessing the early stages of a transformation. That recognition marked the end of simple passage and the beginning of engagement, because from this point forward, 3 at last would have to be watched, not just for where it was going, but for how it continued to change as it went. Heat does not arrive everywhere at once, and this simple physical truth becomes profound when applied to an object like 3 Atlas, moving through unfamiliar light. As 3 Atlas approached the inner region of the solar system, sunlight began interacting with the surface immediately, yet the interior responded on a different schedule, governed by conduction, porosity, and time. This delay between exposure and response is known as thermal lag, and for 3 Atlas it quietly shaped everything that followed. At the surface of 3 Atlas, energy from the sun was absorbed and re-emitted almost instantly, driving visible activity that telescopes could record with ease. Beneath that surface, however, heat moved slowly, threading its way through layers of dust ice and fractured material that had never experienced sustained stellar radiation before. 3. Atlas therefore existed in two thermal realities at once, with the exterior reacting in the present, while the interior remained anchored to the past. As heat migrated inward, pressure began to rise in places that were previously dormant, because volatile ices respond not only to temperature, but to confinement. In the interior of 3I Atlas, sublimation did not occur in open space, but within cavities and microchannels where expanding gas had nowhere to go at first. This trapped expansion built stress, gradually storing energy rather than releasing it immediately. The significance of this process lies in its timing, because delayed heating means delayed response, and delayed response can appear sudden once a threshold is crossed. 3I Atlas did not need a dramatic increase in solar intensity to change its behaviour, because the change was already cued beneath the surface. When internal pressure finally overcame structural resistance, the release appeared abrupt, even though its cause had been forming quietly over weeks. This relationship between heat pressure and delay explains why activity patterns in 3I Atlas could shift after the closest approach to the Sun had already passed. While external conditions were becoming gentler, internal conditions were still intensifying, and that mismatch created a window where new vents could emerge unexpectedly. 3. Atlas therefore carried the memory of heating forward in time, responding late to an encounter that had already ended. As pressure redistributed itself through the interior, it did not do so evenly, because internal structure is rarely symmetrical. 3. Atlas likely contained regions of varying strength and composition, meaning that some layers yielded earlier while others resisted longer. This uneven yielding translated into uneven outgassing, which in turn altered how forces were applied to the body as a whole. The concept of thermal lag reframes apparent unpredictability as delayed inevitability, because what seems sudden at the surface is often the endpoint of a slow internal process. For 3I Atlas, the sideways forces detected later in its trajectory were not anomalies born in isolation, but expressions of energy that had been accumulating since the first moments of solar contact. Understanding this delay allows the motion of 3I Atlas to be seen not as erratic, but as temporally displaced. In this light, 3 Atlas becomes less a passive traveller and more a system absorbing, storing, and eventually releasing energy according to its own internal clock. That clock does not tick in step with orbital milestones, and it does not reset when distance from the Sun increases. As long as heat continues to migrate inward, 3 Atlas remains engaged in a process that unfolds on its own timescale, quietly shaping the path ahead. As internal heat continued to migrate through the body, the places where energy finally escaped no longer mirrored one another, because symmetry is a fragile condition inside a structure shaped by fractures and history. 3 Atlas had likely carried countless microchannels formed long before it ever encountered the Sun, and those pathways did not open in unison when pressure rose. Instead, certain outlets yielded first, allowing gas to surge outward, while neighbouring regions remained sealed, and that imbalance quietly redefined how 3 Atlas interacted with space. In idealized models, outgassing is often treated as broadly distributed, with vents opening across the sunlit hemisphere in a way that averages out directional effects. 3 Atlas resisted that simplification because the evidence pointed toward a smaller number of dominant escape routes taking control of the process. When gas preferentially exits through limited openings, thrust ceases to cancel itself, and motion begins to reflect the geometry of those vents rather than the geometry of the Sun. Asymmetry in venting does not require violence, because it can emerge from gradual changes in permeability and strength. 3. Atlas may have developed hardened crusts in some regions while remaining porous in others, creating a landscape where pressure sought the weakest path rather than the most central one. Over time, repeated flow through the same outlets would widen them further, reinforcing their dominance and suppressing alternative routes. This feedback loop is subtle but powerful, because once an asymmetric pattern establishes itself, it tends to persist even as overall activity declines. 3. Atlas therefore did not need increasing energy input to maintain imbalance, because the structure itself had already been altered by earlier releases. The vents that remained active shaped not only the visible coma, but also the invisible forces acting on the nucleus. Observationally, this process manifested as a skewed inner coma and a jet structure that refused to align neatly with solar direction. 3 Atlas appeared to breathe more strongly on one side than the other, and that uneven breathing imparted a steady lateral push, detectable in orbital calculations. Such behaviour is not unprecedented among comets, yet it is rare to observe it so clearly in an interstellar object undergoing its first close stellar encounter. The deeper implication of asymmetric venting lies in what it reveals about internal organisation, because vents are surface expressions of subsurface pathways. 3 Atlas was effectively advertising where its internal fractures connected to volatile reservoirs, mapping its interior through motion rather than direct imaging. Each sustained jet acted like a tracer outlining hidden structures that no telescope could otherwise see. As asymmetry became established, the forces acting on the body began to reorganize its rotation, because thrust applied off-center produces torque as well as translation. 3 Atlas likely experienced subtle changes in spin orientation, as a result further reinforcing the dominance of certain vents while diminishing others. This coupling between rotation and outgassing created a dynamic system where cause and effect blended into a continuous loop. The loss of symmetry therefore marked more than a surface irregularity, because it signalled that 3 Atlas had entered a phase where internal structure dictated external behaviour. Rather than responding uniformly to sunlight 3 Atlas responded according to its own weaknesses and pathways, revealing individuality, where models often assume sameness. In that individuality, the object ceased to be a generic interstellar comet and became a specific physical system with a unique history. By recognizing that the vents were no longer balanced observers, gained insight into why the trajectory required revision and why future behavior remained uncertain. 3 Atlas was no longer shedding material evenly, and even small imbalances sustained over time could reshape its motion in measurable ways. The asymmetric vents thus became both a symptom and a driver of change, anchoring the story of 3 Atlas in the quiet mechanics of internal evolution, rather than in sudden disruption. As asymmetric venting persisted, its influence extended beyond translation and into rotation, because any force applied away from a centre inevitably tries to twist the body that receives it. 3 Atlas did not rotate in isolation, but responded continuously to the uneven release of material, and over time that response accumulated into measurable change. What began as a slight imbalance gradually expressed itself as a shift in the rotational behaviour of 3 Atlas, subtle enough to escape immediate notice, yet steady enough to alter the long-term pattern. Rotation is not inferred directly, but read through light, because variations in brightness trace how an irregular surface turns in space. For 3 Atlas, the light curve began to evolve not through a sudden jump in period, but through a reshaping of its internal rhythm. Peaks that once arrived at predictable intervals started to shift in timing and prominence, indicating that different regions of 3 Atlas were taking turns asserting themselves. This change suggested that the spin axis of 3 Atlas was no longer fixed in its earlier orientation. A rotating body subjected to off-center thrust experiences torque, and torque does not simply speed rotation up or slow it down, but can also tilt the axis itself. 3 Atlas therefore began to reorient how it presented its surface to the Sun, changing which regions received the most energy and when. As the axis drifted, vents that were once favourably aligned lost their advantage while others gained exposure. 3 Atlas entered a feedback cycle where altered rotation changed heating patterns, and altered heating patterns reinforced the vents driving the rotation. This interplay did not require instability in the dramatic sense, but it did require time because small torques accumulate slowly before their effects become obvious. The migration of the spin axis also offered a natural explanation for why new activity appeared even as overall solar influence weakened. 3 Atlas could activate previously shadowed regions simply by turning them into sunlight, allowing buried volatiles to respond to energy they had not encountered before. In this way, rotation became not just a consequence of activity, but a driver of further change. From an observational perspective, the evolving light curve of 3 Atlas acted as a window into this internal rearrangement. Secondary brightness peaks grew sharper, and their phase shifted relative to the primary signal, implying that multiple active regions were now contributing more equally. Such complexity is difficult to reconcile with a rigid, unchanging spin state, but aligns naturally with a body whose axis is slowly wandering. The importance of axis drift lies in its persistence because once established, it tends to propagate its effects forward. 3 Atlas did not need to tumble chaotically to experience significant reorientation, because even a gradual tilt could redirect thrust in a consistent way. Over many rotations, that redirection compounded, reinforcing the sideways forces already detected in the orbital data. As the axis of 3I at last continued to adjust, prediction became more challenging, not because physics failed, but because initial conditions were no longer static. Each new configuration altered how 3I at last interacted with sunlight gas release and internal stress, creating a system that evolved with each turn. This evolution did not imply imminent breakup, but it did imply that the object was still searching for a stable rotational state. The shifting axis therefore represented another layer of transition, adding depth to the story already unfolding. 3 at last was not merely venting unevenly, and not merely drifting sideways, but was reorganizing how it spun through space. In that reorganization, the motion of 3 Atlas became a record of its internal struggle to adapt written, not in sound or light alone, but in the quiet geometry of rotation. When all of these processes are considered together, a broader picture begins to form because heat migration, asymmetric venting, and axis drift do not act independently inside a small body. 3. Atlas was experiencing these influences simultaneously, and their interaction suggested not a series of isolated events but a single extended phase of internal reorganization. Rather than reacting once and settling down, 3 Atlas appeared to be adjusting continuously, as if the object itself were searching for a new configuration that could endure the stresses imposed upon it. Internal restructuring does not require collapse or explosion, because it often proceeds through gradual redistribution of stress. Inside 3 Atlas, layers of material with different strengths and compositions likely responded at different rates, allowing some regions to deform while others resisted. As volatile reservoirs were depleted or newly accessed pressure pathways shifted, and the internal balance that once held 3 Atlas together in a particular shape began to evolve. This process can be imagined not as destruction, but as reorganization, where old pathways close and new ones form in response to changing conditions. 3 Atlas likely contained networks of fractures inherited from its formation environment, and those networks did not activate all at once under solar heating. Instead, 3 Atlas revealed them sequentially as heat and stress penetrated deeper, altering how forces were transmitted through the body. As restructuring progressed, the surface became a map of internal change rather than a static boundary. Jets emerging from 3I Atlas marked the locations where internal adjustments reached the exterior, translating hidden processes into visible motion. Each persistent jet indicated not just activity, but stability within change, because only pathways supported by the evolving structure could remain open over time. The concept of a self-restructuring body helps explain why 3 Atlas could exhibit consistent lateral forces without exhibiting obvious fragmentation. Rather than breaking apart immediately, 3I Atlas appeared to be redistributing stress internally, allowing deformation to occur without catastrophic failure. This behavior suggests a material strength sufficient to accommodate change, even as internal geometry was being rewritten. As stress redistributed, feedback loops emerged that further shaped the evolution. 3 Atlas experienced altered rotation due to uneven thrust, which changed illumination patterns, which in turn modified where internal heating was strongest. Those changes fed back into vent activation, reinforcing some regions while allowing others to fall dormant, gradually sculpting a new internal equilibrium. Such feedback-driven restructuring is slow compared to dramatic breakup events, yet it can be more consequential in the long term. 3 Atlas did not announce its transformation through sudden brightening or visible splitting, but through persistence and coherence in its changing behavior. That coherence implied an underlying structure capable of channeling forces rather than dispersing them chaotically. The significance of this phase lies in its timing, because restructuring occurred after the most intense solar heating had already passed. 3 Atlas therefore demonstrated that internal evolution can lag behind external conditions, continuing long after the triggering encounter has ended. This delayed response underscores the importance of internal timescales, which do not align neatly with orbital milestones. From a physical perspective, restructuring represents an attempt to reconcile internal and external demands. 3I Atlas was balancing the need to release pressure against the need to maintain integrity, and the outcome depended on how effectively stress could be redistributed. Each successful adjustment allowed 3I Atlas to persist as a coherent body, while each failed pathway would have increased the likelihood of fracture. As observers tracked these changes, the narrative shifted away from static classification and toward dynamic interpretation. 3I Atlas was no longer described simply as an interstellar comet, but as an evolving system undergoing adaptation. This shift in perspective acknowledged that the object's present behaviour could not be understood solely through its past state. The idea of self-restructuring also reframed uncertainty as a natural consequence of evolution, rather than as a lack of knowledge. 3 Atlas was not unpredictable because it was mysterious, but because it was actively changing, and changing systems resist simple forecasting. Accepting this reality allowed future observations to be framed as continuations of a process rather than tests of a fixed model. In recognizing 3 Atlas as a body in transition, researchers implicitly accepted that multiple outcomes remained possible. 3 Atlas could eventually settle into a new stable configuration with activity diminishing as internal stresses relaxed. Alternatively, continued restructuring could weaken critical regions, increasing the chance of fragmentation later on. At this stage, however, the most accurate description was neither stability nor failure, but transformation. 3 Atlas was reshaping itself in response to forces it had never encountered before, using its internal structure as both constraint and guide. In that quiet, persistent reconfiguration, 3 Atlas revealed that passage through a star system is not merely a journey through space, but a negotiation between history, material, and change. As 3 Atlas continued along its revised path, the accumulation of evidence narrowed the range of physically plausible futures, because systems undergoing reorganization tend to resolve themselves in only a limited number of ways. 3 Atlas did not exist in a state of open-ended possibility, but within boundaries set by material strength, internal geometry, and the persistence of stress redistribution. From that perspective, the unfolding behavior of 3 Atlas pointed toward 2 broad physical pathways, neither of which required speculation beyond established mechanics. The first pathway involved stabilization through redistribution, where internal restructuring gradually reduced imbalance rather than amplifying it. In this scenario, 3 Atlas would continue adjusting until dominant vents aligned more favorably with the evolving spin axis, allowing thrust to cancel itself more effectively over time. As torque diminished, rotation would settle into a more consistent orientation, and the lateral forces detected earlier would weaken rather than intensify. Such stabilization does not imply a return to the original state because the original configuration has already been lost. 3 Atlas would emerge from this pathway altered, but coherent, carrying scars of its encounter while maintaining structural integrity. Activity would persist at lower levels, yet the system as a whole would behave more predictably as internal feedback loops converge toward balance. The second pathway followed a different logic where restructuring failed to relieve stress and instead concentrated it in vulnerable regions. If internal adjustments continued to redirect force without achieving equilibrium, 3 Atlas would experience ongoing torque and uneven pressure that exceeded the capacity of its material to adapt. In that case, gradual deformation could transition into fracture, not through a single dramatic event but through cumulative weakening. Along this pathway, vents would continue to migrate and multiply, preventing any stable orientation from forming. 3 Atlas would rotate in a state of persistent adjustment, exposing new regions to heating while old pathways collapsed. Each change would add complexity rather than resolving it, increasing internal strain with every cycle. What distinguished these 2 paths was not external influence, because solar input was already declining, but internal response. 3 Atlas was no longer being driven primarily by changing environment, but by how effectively its structure could reorganize under existing conditions. This distinction placed the future of 3 Atlas squarely within the domain of its own physical makeup. Observationally, the divergence between these paths would reveal itself gradually rather than suddenly. A move towards stabilization would manifest as consistency, with jets holding orientation and rotational signals simplifying over time. A move toward failure would instead show increasing complexity, with newer symmetries emerging faster than old ones could fade. At the present stage, the data did not compel a conclusion, because indicators from 3 Atlas remained compatible with both outcomes. The object exhibited coherence alongside change, suggesting resilience, yet also displayed persistent imbalance, suggesting vulnerability. This coexistence placed 3 Atlas in a transitional regime, rather than at a decisive endpoint. The importance of recognizing these 2 physical pathways lay in restraint, because it prevented interpretation from drifting toward extremes. 3 Atlas did not need to be imagined as either fully stable or imminently breaking apart because transitional systems often occupy an intermediate state for extended periods. By framing the future in terms of physical limits rather than narrative drama, the behaviour of 3 at last remained grounded in mechanics. In this way, the story advanced without resolution because 3 at last had not yet committed to either path. The object continued to move forward, carrying both possibilities within its structure shaped by forces already in motion. What remained was observation, not prediction, because only continued change would reveal which physical outcome 3 at last would ultimately approach. As time progressed, the defining feature of 3 at last was not collapse, and not stability, but delay, because balance is not something that appears instantly when forces begin to shift. 3I at last existed in a window where competing influences were still negotiating, and that negotiation unfolded slowly enough to be visible in the data. In this intermediate state, 3 at last neither returned to symmetry, nor crossed into failure, but remained suspended between adjustment and strain. A system seeking balance must dissipate excess stress faster than new stress is introduced, and for 3 at last that condition had not yet been met. The asymmetric vents continued to apply uneven thrust, while the drifting spin axis redistributed sunlight in ways that activated new regions before older ones could fully quiet down. As a result, 3 at last experienced overlapping cycles of change where resolution in one area coincided with emergence in another. This overlap created a pattern that looked unsettled without being chaotic, because the behaviour of 3 at last retained coherence even as it evolved. Jets held their general orientation for measurable intervals and rotational signals, though complex did not dissolve into noise. Such coherence suggested that 3 at last still possessed internal pathways capable of channeling energy rather than dispersing it indiscriminately. At the same time, the absence of equilibrium remained evident because no configuration persisted long enough to become dominant. Each tentative alignment was followed by subtle deviation, and each apparent settling was offset by renewed activity elsewhere. 3 at last therefore behaved like a system adjusting its posture repeatedly, unable to find a position that relieved pressure across its entire structure. The physical reason for this delay lay in internal heterogeneity, because materials with different strengths respond on different timescales. Within 3 at last, some layers likely accommodated stress through deformation, while others resisted until thresholds were reached. This staggered response prevented the object from redistributing forces uniformly prolonging the transitional phase. As balance failed to form quickly, time itself became a critical variable. 3 at last was no longer reacting to a changing external environment, but to the accumulated consequences of its own past responses. Each rotation carried forward the imprint of earlier adjustments, shaping how new stresses were applied and absorbed. From an observational standpoint, this condition manifested as persistence without resolution. Measurements showed continuity from one day to the next, yet also revealed incremental drift, indicating that 3 at last was evolving without converging. This pattern is characteristic of systems near thresholds where small changes matter disproportionately. The uncertainty introduced by this delayed balance did not imply unpredictability in principle, but it did limit forecast confidence. 3 at last could not be extrapolated far into the future without assuming stability that had not yet emerged. Instead, each new observation functioned as a check on whether internal adjustments were damping out or compounding. Emotionally, though unspoken in scientific language, this phase carried weight because it represented a moment of genuine openness in the object's evolution. 3 at last had not yet chosen a physical outcome, and the data reflected that indecision through gradual change rather than decisive motion. Such moments are rare because many systems resolve themselves quickly or fail abruptly, leaving little to observe in between. In remaining unbalanced without disintegrating, 3 at last occupied a narrow region of possibility. This region allowed internal restructuring to continue, while preserving overall coherence, a condition that cannot persist indefinitely. Either balance would eventually form, or stress would accumulate beyond what the structure could accommodate. For now, however, 3 at last continued within this unresolved state, carrying both resilience and vulnerability forward together. The object moved on not as a finished system, but as an ongoing process defined by the absence of a conclusion, rather than by its presence. As observations continued to accumulate, attention shifted toward identifying which signals might distinguish endurance from failure, because systems near transition often reveal their future through subtle trends rather than sudden events. 3 Atlas presented such trends quietly embedded in continuity rather than disruption, and those trends demanded patience rather than urgency. The task was no longer to explain why change had begun, but to recognize whether change was converging toward coherence or diverging toward instability. One sign associated with resilience lies in repetition, because sustainable configurations tend to reinforce themselves over time. 3 Atlas showed moments where jet orientations persisted across multiple rotations, suggesting that certain internal pathways were capable of maintaining flow without rapid degradation. When thrust directions remain coherent rather than wandering, it implies that internal stresses are being redistributed rather than amplified. Another indicator of durability appears in rotational behavior, because stable bodies tend to simplify rather than complicate their motion. 3 Atlas displayed intervals where brightness patterns became more regular, even if only temporarily hinting that the spin axis was exploring configurations that reduced torque. Such moments did not represent equilibrium, but they suggested that equilibrium was at least physically accessible. In contrast, signs of potential failure emerge through acceleration of change, where new features appear faster than old ones can fade. 3 Atlas occasionally exhibited this pattern as well, with fresh activity emerging before prior asymmetries had diminished. This overlap implied that internal adjustments were not yet damping out, raising the possibility that stress was migrating rather than resolving. Structural weakness does not announce itself through collapse alone, because it often manifests first through inconsistency. 3 Atlas would signal vulnerability if rotational signals grew increasingly irregular, or if thrust directions fractured into multiple competing components. Such fragmentation would indicate that internal pathways were failing to channel pressure effectively, allowing stress to spread unpredictably. Equally telling would be changes in coherence across datasets, because a single evolving structure tends to leave consistent signatures in position, brightness, and morphology. 3. IATLAS continued to display alignment between these independent measures, suggesting that its behavior, though changing, remained governed by a unified internal system. This unity argued against imminent disintegration, because fractured bodies rarely act as a single entity for long. Time also functioned as a diagnostic tool, because persistence itself can imply strength. 3 at last maintained integrity across repeated cycles of heating rotation and outgassing, indicating that its material properties had not yet been exceeded. Each day without fragmentation narrowed the window in which sudden failure remained likely. Yet endurance should not be confused with permanence, because systems can remain intact, while still trending toward eventual breakdown. 3 at last existed in this ambiguous zone, where survival in the present did not guarantee survival in the future. The distinction between delayed failure and genuine stabilization could only be drawn through continued observation. The balance between these signs created a tension that resisted resolution, because evidence pointed in both directions without decisively favoring either.